Now that we've focused on identifying an acid and a base, I'd like to talk about conjugate acids and bases, which honestly you can identify in the exact same way. The trick to something being a conjugate acid or base is that it's a product. So in our acid-base reaction, we know that the hydrogen that's bonded to our acid will break its bond to the acid and leave the electrons behind. And it'll form a bond with the lone pair on our base right here. So then our base gains an extra hydrogen and our acid has a lost one. So if we look at our products, we can see that actually we still have an acid and a base, they've just switched roles. So when our acid lost its hydrogen, it gained the electron from that hydrogen and it formed a lone pair. And a lone pair that can form a bond to a hydrogen is our definition of a base. Similarly, our base, when it formed the bond to the hydrogen, gained a hydrogen that can bond, that can be broken, which is our definition of an acid. And so when we talk about our products of an acid-base reaction, we refer to them by this identity of acid and base, but we distinguish it from our reactants by calling them conjugates. It's a way of saying like the product base. So when we have an acid, it will always form a conjugate base because it has lost that hydrogen and the result is that lone pair. And when we have a base in a reaction, it's going to always form a conjugate acid. So the acid and base forms a product that is its opposite. And we can call these a lot of times, we call them, oh, too far, acid base conjugate pairs. So the HA acid would be a pair with the conjugate base A minus. Here, let's look at an example of hydrobromic acid reacting with water. So in this case, we have an acid that has that hydrogen bonded to it that can break. That bond breaks and the oxygen on my water has two lone pairs, one of which forms a bond to that hydrogen when that bond breaks between them. And that produces hydroxide ion. Notice that I went from a 2 subscript to a 3 subscript in my water. So what was a base now becomes a conjugate acid because it has this extra oxygen hydrogen bond that can break. So my base conjugate acid pair would be water and hydronium ion. Now my acid, it loses this hydrogen and produces instead bromine, which has an additional lone pair. It already had 3, so now it has 4. And so with all of these lone pairs and no hydrogen, this is a base. It's a conjugate base. So the acid conjugate base pair is hydrobromic acid and Br minus. Notice that the difference between these two is just a hydrogen atom. So here you see in the water hydronium ion, you see that difference in the subscript. In the hydrobromic acid and bromine, you actually see a missing hydrogen. Let's walk through an example of this. And feel free to pause the video here, try this on your own, and then continue the video to see the solution. Okay, so looking at these, I'm going to try to determine what the conjugate base or acid is. So when I'm asked to identify the conjugate base, that gives me a hint that I'm actually looking at an acid. This is sulfuric acid. So to determine the conjugate base, I am going to remove one hydrogen. I'm going to get rid of a hydrogen. So that means when I'm rewriting my chemical formula, I'm going to have 2 minus 1, then SO4. So really this is equal to 1 hydrogen bonded to S and 4 oxygens. Now this is a neutral molecule. There's no charge here. So when I lose this hydrogen, it leaves behind an electron. So I'm going to gain a -1 charge. I'm going to go from 0 to -1. And here is my answer. Now let's look at our second one. This is asking for the conjugate acid, which makes this a base. And looking at this, there are hydrogens, but they're coming after the carbon. And then I have an oxygen and a negative charge. So because oxygen's more electronegative than carbon, it's very likely that the oxygen has the negative charge on it and has 3 lone pairs. In fact, when we look at this, it's got a carbon double bonded to one oxygen and single bonded to another. This is acetic acid. So the place that a hydrogen will bond then is to this place that has all these extra lone pairs. So when I rewrite this, I'm going to add a hydrogen. And that's going to look like CH3 still, CO2, and now I just add an H at the end. And since I was at a -1 charge and I gained a proton, I'm going to go to 0, or -1 plus 1 equals 0. So this will have a 0 charge that I can omit. It's kind of like just forming a hydrogen bond here. So for my conjugate acid, I'm just adding a hydrogen and adjusting the charge. For a conjugate base, I'm removing a hydrogen and adjusting the charge.